Hi, everyone. Thanks for joining me today. I'm really excited to talk to you about how I think digital technologies are impacting how consulting engineers work today. My name is Akira Jones, and I'm a principal at H. Angus and Associates. I'm currently the BIM leader there. Now, H. Angus has been in business for about 100 years, and this organization has seen a lot of change from drafting on paper, the introduction of computers and computer-aided design, and the shift towards BIM and database-driven design technologies. However, the rate of change in technology and the availability of technology is certainly not something we've experienced before. Now, to get started, let me tell you a little bit about myself. I came to H. Angus in 2012, and I have a background in project engineering in the commercial sector, healthcare sector, and I've done some work in data centers. And I joined H. Angus to support the team designing the massive Shroom Hospital. And from there, the BIM team grew at H. Angus. Initially, the team was created to help designers at H. Angus in our BIM-related activities and projects. And this meant providing support using the database-driven technologies associated with BIM, developing our reality capture and scan-to-BIM capabilities, and any of the other tools around using Revit or BIM processes. Over the last 10 years, this has taken me and the team into exploring digital twinning, smart buildings IoT, and cloud technologies. And through a variety of pilot and research projects, I've had the opportunity to work with folks with a lot of different skill sets that I think will be very valuable for the future consulting engineer. I think there's a vast potential to really leverage and really supercharge our ability to solve problems for our clients. So I'm just going to quickly review our agenda for today. I'm going to briefly talk to you about the changing landscape of the AEC industry. I'll explore some of the skill sets that I think will be really important for the consulting engineer and how they can be leveraged in the future to improve our work or provide new services based on some of the research and pilot projects that we have worked on internally or with academic institutions over the last 3 or 4 years. And finally, I'm just going to conclude with some of my final thoughts. Now, it's pretty obvious for me to say that the future is changing how we all work. The pandemic has also made a drastic shift in that as well. But I would say that the construction industry, at least in the past, was typically very slow to change. Its means and methods, whether that's on the design side or on the construction side, have up until recently largely been the same. But you can see the changes that are happening in the industry today. There is a much higher rate of the adoption of technology, and there's a much larger variety of technologies that are available to us in construction, whether that's from 3D scanning technologies, estimating software, CFD software, energy modeling software, and 3D modeling technologies. And honestly, the list goes on and on and on. There is so much stuff available in the market today. And there's certainly a shift in the potential level of efficiency of design and construction. And part and parcel to that, I think there's a much higher expectation on the client side to deliver more. Cost often drives the end product. And I think a term that many of us hear regularly is value engineering. I think to a lot of us, this has negative connotations, but I think we can provide value add engineering and use new technologies to improve our efficiency, improve our workflow, provide novel solutions, and improve the overall quality of the product we deliver. As a small example, we can see my colleagues here, Melissa and Steve, using a VR headset to coordinate in a virtual environment. Now, I'm just going to add the obligatory, this was done pre-COVID, as this is not something that we'd probably want to be doing right now. But tools like this have a variety of applications, from training new grads, bringing designs to life before they're even built, and giving an opportunity to coordinate in an in-context environment. Now, the AEC market is also changing very rapidly in other ways, not just in terms of the adoption of technology. I think one of the most interesting things with the emergence of these disruptive technologies is the entrance of non-engineering sectors into the AEC market. Number one, professional service companies. Now, we are in the era of smart buildings, IoT, big data, and cloud. And big data and cloud are the bread and butter for large professional service firms. And these technologies will play a really important part of the operation of new and existing building assets in terms of collecting the data from legacy building systems and future building systems like IoT. And these folks are very much interested in how cloud solutions can be provided to our clients. Now, big tech and tech startups are also developing platforms that are providing solutions around the building operations, system optimization, fault detection and diagnostic, and digital twins. And these products, although providing solutions for the end user, are also large data collection engines. And this data will be used in a variety of different ways, but again, all focused on optimizing the built world. And I think Google and Sidewalk Labs is a really great example of how a tech company is getting into real estate development and building infrastructure. And so much like the rest of the world, the AEC market is converging towards digital processes. In fact, you see a lot of the larger multidisciplinary firms or general contractors or mechanical and electrical contractors have groups within them that are dedicated to software programming, whether that's developing in-house software or developing software that they will market out to the world. And just a few examples, Ellis Dawn has a digital services team that provides managed services to their clients. Modern Niagara provides building intelligence services and master systems integration services to their clients. And IBI has a dedicated software development group providing software solutions to their clients. So what is the impact to our core business? I think as a consulting engineer, there are several. There are impacts in terms of how we can execute our work. There are impacts in terms of the technologies that we can bring to our clients. And there's impacts in terms of the services that we can provide to our clients. And the impact, I think, is also on the expectations of our clients in terms of the problems that they're expecting us to solve. And this may mean working with different solutions providers than we're typically used to, whether they're management consultants, cloud consultants, or even tech startups. So with all these pressures on our industry, where does that leave a consulting engineer? I think ultimately we have to capitalize on the advantages that we have. We have a unique insight into how a building operates, whether that's from having been the designers or having worked at the facility for many years. We understand how these assets operate and how they work. And we are often considered the trusted partners for our clients. We are uniquely positioned to bring new technologies to our clients and provide new solutions to them as well. We just need to understand them. So we have to reframe the type of problems that we're solving for our clients. And with that, we need a vaster understanding of all the technologies that are available to us. As an example, when you think about designing a project using Revit MEP, which I would say is the primary 3D design tool in North America, there are a lot of different third-party tools that work and integrate within the Revit environment. And that can be a lot to understand, not just for the designers, but for everyone along the management chain. You need to understand how the work is produced to maximize its efficiency. And as I've touched on before, with the emergence of IoT within the building industry, our understanding has to evolve beyond just how chillers and boilers work and how BAS and lighting control systems work. We must now understand a lot of different technologies and a lot of different software applications. These are applications like Willow and ThoughtWire, which are digital twinning platforms, Brainbox AI, which is an asset energy efficiency management platform, Clockwork Analytics and Coppertree, which are like fault detection and diagnostic platforms, and even Microsoft Azure Digital Twin, which is an IoT platform for creating digital twins for a variety of sectors. And the image you see on the screen here is actually a Revit model that we have put onto the Autodesk Forge platform, which is Autodesk's development platform for bringing IoT into BIM models. So what is the opportunity here? Because I really feel like there is an opportunity for consulting engineers. There's a lot more for us to have to understand out there, but it could potentially transform how we approach our work. And I think the distinction between a knowledge worker and a software solutions provider and a cloud expert are certainly converging because the future will require an understanding of all of these things. If, you're, if we are able to change the type of solutions we can offer, this may also afford the opportunity to change how we generate revenue from a project to project model, shifting towards a recurring revenue source. Let's take a look how I think we can potentially do that. So to get into the next section here, what skill sets do I think consulting engineers need for today and for tomorrow? Because I truly believe that the consulting engineer of the future is a very different beast than that of the last 20 years. I think the primary skill set is going to be around software development. This will be true for a lot of industries, and it's not just the knowledge of how to program software, it's understanding what software is capable of from a small to large scale. As an extension of software, understanding machine learning and AI is certainly something that is going to be a skill set that I think is going to play a very important part of a consulting engineer's future, whether again, that's understanding how to create it or leverage it. And I also think that understanding of IoT will be important. However, I mean this in a much broader sense. The skill set is going to be around understanding cloud technologies. This is going to be an important factor for consulting engineers as well. In a minute, I want to share with you some of these projects that we've worked on recently to showcase why those skill sets will be important. So before we get into the next section, I have a few polls that I want to do with you, and we're going to address the results of the poll at the end of the presentation during the Q&A period. So number one, do you currently have any full-time developers on staff? And you can go to the right side of your screen to put in your answer. Number two, do you think you should have software developers on staff? So software development, this is certainly a large topic to unpack, but it's going to be a really important skill for consulting engineers. Perhaps everyone knows someone in their organization that has a knack for programming. They can write macros, they can code in VBA, or they're using Dynamo within the Revit environment. Keep in mind, I'm not saying that every engineer needs to know how to code or write software. One of the main skills for engineers is understanding how software can improve process, because I think this is a skill in and of itself. It's extremely important to understand how you can use software to automate some of your processes internally or iterate in ways that would take a human a lot of time. Thinking back to my days, my designing days or my Revit modeling days, there's a lot of things that were very repetitive about this design process. And this is the type of activity that, if automated, has a lot of potential to making work more efficient. For instance, renaming a series of elements within your drawings or models based off a new numbering scheme for your security cameras or terminal units was often a very time-consuming process. A lot of design work is extremely repetitive. And I think the opportunity to use software programming in-house so that you can automate these processes has a lot of potential. The application programming interfaces, or APIs, for our design software such as Revit or Rhino gives us the opportunity to easily automate these tasks, made even easier with visual programming languages such as Dynamo or Grasshopper. And not only can we use these APIs for simple automations, but they can be used for more sophisticated processes, such as running parametric simulation for space loads or extracting data from our models to validate design assumptions and inform future designs. And I'm going to give you a couple examples from Angus. So this video shows you the potential of parametric simulations using an optimizing algorithm. This is a visualization of the different solutions that were created while optimizing based on space load, while iterating on window to wall ratio, shading size, and building orientation. So changing all of these parameters, we were able to run thousands of simulations and visualize the results of that to see which one was optimal. Now, I'd like to tell you that we came up with this, but this is based off of open source code that is available on the internet. This is available to anyone right now. And this is an example of a piece of code written to extract duct surface area from a Revit model. The script also calculates the duct leakage based on duct pressure class. And again, this was all created using nodes from libraries readily available on the internet. And there are tools available to us right now that we can easily improve how we do our work or validate our typical assumptions that we make at the beginning of projects and use data to inform our future designs based off of similar type projects. Now, beyond that, I think there's a major opportunity for consulting engineers to provide unique solutions to their clients. It seems a bit far-fetched to say that, okay, every consulting engineer is going to become a software provider. However, reaching a bit further than just say simple automations through research partnerships and pilot projects can provide valuable insight, intellectual property, and provide the potential for creating something truly novel or marketable. A great recent example for this at Angus was a research partnership with Queen's Ingenuity Lab through the Ontario Centre of Innovation. This project's long-term goal was to look at the potential of computer vision in a clinical setting. The first phase focused on developing a video communication platform for clinical staff with the aim of reducing PPE usage during the height of the pandemic. The idea was to create a two-way video communication platform that was gesture-based and used facial recognition to identify the user so as to reduce the number of physical touch points when using the system. And this would allow staff to determine the patient's needs before entering the room, potentially reducing the requirement to don and doff PPE. So developers at Angus worked closely with the folks at Queen's developing the platform. Angus's team looked at creating the backend database, while the Queen's team developed the front end and elements related to facial recognition and gesture-based control. Now, it was a really interesting experience to work on a project like this, and we were able to roll out 2 units at Quinte Healthcare for testing, which are still being used today. And that's what you see on the screen here. You see the tablet in the patient room, and you see the tablet located outside the patient room. And we got a lot of really good feedback from the clinical staff that were using it. Now, this was a complete investment from our part in time for us and really outside of our wheelhouse, but it gave us the opportunity to look at a particularly unique challenge and gave our team the chance to learn about an area in software that was new to us. Now, like I mentioned previously, we all have those folks in our organizations that tinker with software. Now is the time to give these folks some runway to see how they can improve your organization or create something new. Organizations should give these folks some space to take this off the side of their desk and give them the time and resources to go beyond just tinkering. When looking at our new recruits, I actively look for folks who have an interest or some experience in software programming, because beyond creating solutions themselves, the mindset can have a lot of value within your organization. Now, I think this provides us a good segue into machine learning, which is the next topic I want to talk about. So we're going to do another poll here. I'm just going to direct you to the right side of your screen. Is machine learning AI at the point it's reasonably accessible to the average engineer in our workflows? Now, machine learning is a term that gets thrown around a lot and can be misused or I think misunderstood. For instance, there is a vast difference between predictive analytics, which would use a data set to inform future patterns, versus true machine learning, which would take data and generate a model of a system and then use new data points to predict outcomes. We are at the point now that I think this technology is available to the average engineer. This, quite frankly, was news to me. However, we have had the opportunity to work with Ryerson University's Architectural Sciences Department and one of our commercial clients to show how you could create a purpose-built digital twin using existing data sources and machine learning to model a system's behavior in a building. We worked with a long-standing client of ours that has had a recurring issue with stack effect in one of their commercial towers. For those of you who may not be familiar with stack effect, this is air movement through a building due to a difference in density of air outside the building versus the air inside the building. For example, in the winter, the outdoor air is much colder than the air inside the building. The warm air in the building rises through the elevator shafts and draws in colder at the bottom of the building. And this leads to an increase in the infiltration of air and therefore energy usage. And this challenge was identified by the Ryerson folks as a good opportunity to show how machine learning can model building behavior. So this project was broken down into 2 phases. Phase 1 used return air temperature at the building's air handling units as a proxy for indicating stack effect. Based on a review of the BAS data, the team at Ryerson noticed that the return air temperature for the upper compartments during a turndown period were higher than that of the lower compartments. Now, this is visualized on the two graphs on the left, the top being from February 2021 and the bottom being from April 2021. Now, this was hypothesized to be a result of a thermal mass moving up through the building due to stack effect. Now, using various data sets that contain data points such as outdoor air temperature, relative humidity, supply air temperature, fan status, and supply air set point, different machine learning algorithms were trained to model for return air temperature. Now, to keep this explanation simple, the simulated model generated for the lower half of the building was able to accurately predict return air temperature based on data from the BAS. This is indicated by the middle graph on the right, where the blue line indicates the actual return air temperature and the green line indicates the simulated return air temperature. Whereas the simulated model generated for the upper half could not accurately predict for return air temperature unless an unaccounted for thermal mass was added to the system. You can see the red dotted line indicating the model with the additional thermal mass correlates more closely to the actual return air temperature. Now, the second phase of this project looked at data from a differential pressure array installed through the building. And this data is currently being analyzed to confirm the results from phase one. Now, there's two takeaways from this. One, the application of machine learning to inform our work is not a future tool. This can be applied today. We just need to find the right use cases for it. And two, not only is this important from a research perspective, this shows that you can potentially learn more about building performance with existing data sources using new methods. A lot of existing buildings with legacy building systems face challenges with operating more efficiently. Upgrading these systems can certainly be a costly endeavor, so the potential of using existing data to inform how to manage building systems provides a less costly path to energy efficiency. For this example, the stack effect model could be used to manage building pressurization more effectively, saving energy from the additional infiltration. So I'm going to move on to our next topic, which is IoT and cloud. And so for the final question for our poll, does your organization have some footprint in the cloud? So it seems obvious to say that IoT, or the Internet of Things, is something that we should be concerned about as consulting engineers. And in and of itself, it is certainly not a skill, it is a technology. And if you look at the industrial sector, mining and manufacturing, IoT is a relatively mature technology, but it is now just making its way into healthcare and commercial sectors. And we are just now learning how to leverage this technology. Beyond that, it's not about understanding the individual edge devices themselves that I think is important, but it's how you gather that data and how you store that data in a common environment and how we incorporate cloud technology into our clients' building infrastructure. Cloud is another word that gets thrown out there a lot, but understanding how Amazon Web Services, Google Cloud, and Microsoft Azure play a part in our future will be a key to our success. Cloud infrastructure will be very important in understanding how IoT technologies and digital twinning technologies can be implemented for our clients and even ourselves. Now, my focus is really on existing facilities. It's relatively straightforward to build a smart building when it's a greenfield site. It's really not that easy to convert existing assets into smart buildings, especially when you're dealing with all of the aging infrastructure. But it's not to say that that's impossible. Now, our understanding of cloud technologies was a journey which started with an internal pilot, and that's what you're seeing on the screen here. You can see an occupancy sensor at somebody's workstation, and you can see the Wi-Fi mesh hub that was gathering all the data from the sensors here. Now, our clients were asking us about what we knew about smart buildings technology. So we partnered with a startup called Argentum and implemented our own smart building solution within our office. We decided to keep it simple and looked at the installation of a series of passive infrared presence sensors and environmental sensors at everyone's workstations. Now, this was all about to start up in the spring of 2020, And of course, we all know what happened then. COVID hit, and so we had a bunch of sensors installed, not monitoring anything. But as time went on, we found that there was certainly a potential for the technology, particularly from an office re-entry point of view. Now, as we pivoted the project within our own office, we learned a great deal about implementing IoT solutions and led us to the opportunity to apply for a grant through the Ontario Centre of Innovation again, which gave us access to the NCORE 5G testbed in Ontario. And from here, we were able to partner with a long-standing healthcare client of ours to pilot an IoT solution using the 5G testbed. Now, I'm going to pause here for a moment because you can see there was a lot of steps in this process, and we didn't really know what those steps were going to be when we were at each stage of the project. But these things happened to kind of open up as we went along, and we just kept on saying yes to the opportunities that were presented before us. So the major question for us was, where was this data going to be stored? For this, and this is where cloud comes into the picture and why I think it's going to be really important. For this particular project, we decided to use Amazon Web Services and a series of different services in that ecosystem to stream data, which is done through the Amazon Kinesis data streams, store the data, which are done through Amazon S3 buckets, which are just database, cloud-based database structures, organize the data, so that use the AWS Lake formations, and visualize the data, which we use the AWS QuickSight platform. So this particular solution that we were looking at with our healthcare client looked at a single use case, collecting presence data to look at the throughput of a specific department in a facility. And this data can be used potentially to determine peak times in that department, non-peak times, whether there were folks in the waiting rooms when the exam rooms were not being used, or if there are exam rooms that are being used more than other exam rooms. There are many different potential use cases looking at presence data. And not only can this inform staff real time, but it can also be used to inform future planning for the planning department based off of how those spaces are currently utilized. Now, we are currently in the initial stages of this project, but the point here is that it afforded us the opportunity to learn about a cloud environment and set up our own cloud environment and learn how these support IoT and smart buildings solutions. We're just at the tip of the iceberg for cloud. And I think when it comes to a lot of organizations, they have some footprint, but has nothing to do necessarily with building systems or building data or IoT solutions. The opportunity exists here to understand these technologies and provide a different form of consulting to our clients so that they can navigate this world that is not as complicated as one might think. And looking at small scale pilots, like the one I just described with our healthcare partner, makes the technology accessible to your clients and makes it accessible to us as well, and gives us the opportunity to learn how we can potentially provide these kinds of solutions. Now, I believe that to be part of the future, we need to expand on what it means to be a consulting engineer. There are fault lines that will emerge in the extremely near future in terms of who is able to leverage these technologies and who is not. And I'm going to use remote work as an example. I think pre-pandemic, a lot of engineering and construction firms saw remote work as a challenge and didn't know how to reconcile that with the way we did our work. But obviously, when the pandemic hit, most of these organizations made a very fast transition. We adopted new technology, we adopted new workflows, and we figured out new ways to communicate. But beyond the remote working itself, I think the organizations that can adapt to this new environment will be the ones that succeed the most. And in a similar fashion, adopting new technology will be much the same. And so I think it's really important for engineering consultants to invest in different skill sets. And from my experience over the last few years, I really see the potential in large to small scale software development, and in particular, getting organizations to look for folks with some background in software or some interest. You can take that small project that's on the side of somebody's desk and give them some space to really flesh out an idea. You never know where it could end up. Machine learning and AI, I think, is going to be really important. And this might seem like it's really far-fetched, but there are commercial AI companies out there providing solutions today. And there are folks out there with the skill sets to implement these processes. This is not a future technology. This is a now technology. And finally, cloud. You can't escape the cloud, so you might as well embrace it and learn what it's all about. It always seems daunting to enter into a new space, but over the last few years, we've had a lot of success by investing in research projects and investing in pilot projects and creating partnerships with academic institutions. And these experiences have really helped us to understand these new technologies, create an environment internally to work more efficiently, create an environment where we could potentially look at creating new services, and giving us access to a different talent pool than we're used to. We're in the business of solving our clients' problems. The fact is that how these problems are solved is changing drastically, and the nature of these problems are changing drastically as well. A lot of these challenges also deal with aging infrastructure. You may have noticed, but most of the pilot projects or research projects I discussed in this presentation were applying new technology to existing building and assets. The challenge in the past was how to design and how to build it. These assets have been operating for a certain amount of years, but they probably have a lot of potential usable life left in them. However, when you look at the challenges in our near future, looking at energy efficiency, greenhouse gas reduction, low carbon, and IoT technologies, bringing new technology and energy efficiency to these assets is certainly a challenge. And what I hope to have shown in this presentation today is that there are important skill sets out there that can generate new opportunities for engineering consultants to solve clients' challenges in novel ways, bring new technologies to them, and help organizations leverage their assets for as long as they can, and to potentially address any kind of challenges within our own organizations. So that's it for today, folks. I really do appreciate the time that you've given and listening to this presentation. We're going to move into the Q&A portion of the presentation now.
Good morning, everyone, and thank you for joining again. My name is Manraj Penu. I'm an engineer here at Spin Master, a leading global toy and entertainment company based out of Toronto. Super excited to be engaging in this topic today. I will be facilitating the Q&A, but I think before we get into that, if we could have the poll results brought back up, and maybe Akira, if you could give us some insights and some thoughts around how the results shook out.
Sure, yeah, that'd be great. Okay, so full-time developers on staff. So 63% said no. I mean, this is somewhat what I would expect, particularly from an engineering consulting firm. And I would say that, a lot of folks probably have people in their organization, like I was saying in the chat, that know how to program software or do small scale type things. But that's somewhat what I would expect, just because we still haven't seen that major transition yet. See, this is the more important answer here. So 77% said yes, and it's an overwhelming majority of folks. I think it's telling the fact that people are recognizing the fact that software development is going to be a key factor in any organization moving into the future. Just because it's the way we'll be able to maximize efficiency through software. Now, this is, I would say that if before maybe a year ago, I would have totally agreed with this. And, I think the challenge here is that, yes, I mean, machine learning AI, it's in one of those things that everybody, it was really hyped up for a while, and, it was going to solve all of our problems. And of course that, that hasn't been the case yet. But the key to using machine learning and AI obviously is asking the right question, and also having enough data. I mean, you need large data sets obviously to really leverage this technology, but it really also comes down to how you frame the problem, how you frame the challenge, and because if you don't do that correctly, then you're not able to model solutions around the questions that you're asking. So I can understand that, and obviously, the technology is not mature, particularly in our sector. I think in the financial sector, it is much more readily used, but obviously they have very, very large data sets that they can leverage. So, but it's interesting result for sure.
Great. Okay. I think with that, we're going to jump into some of the questions. The first one here is, as a mechanical consulting engineer, what is the best way to approach the points you addressed about learning software programming, machine learning, and IoT and cloud, given no software experience background?
Well, I mean, that's certainly that's I know it's often hard to learn something new, and software programming is interesting in that I think that people often assume that if you're really good at math and science and stuff like that, that you're good at software programming. But I feel like software programming is more akin to languages. It is a language. You're learning to speak to a computer. But it, there are lots of courses available. I mean, these days with things like LinkedIn Learning or other online learning platforms, it's really easy to get into it, and it's just a matter of kind of stepping into it. When you look at something like cloud, there are also lots of different certifications that you can look into on the various cloud platforms, so AWS, Google Cloud, Azure, and you could go to various levels of complexity with those and start to understand those technologies. IoT is certainly an interesting one because there's a number of ways that you could approach it. I know folks that are really interested in, for instance, using like a Raspberry Pi and creating their own kind of using sensors and gathering data on their own and kind of tinkering away at that. But the other side of it is the data visualization side and understanding how you can take the data. And so there's when you look at some of the, I guess, more formal courses that are out there, there's lots of masters in data science, or even learning to use BIs like Power BI or Tableau or anything like that. So there's a lot of different ways to kind of get into it. But I would say that the only way is to start somewhere, and there's lots and lots of resources online these days.
Yeah, and I think to that point, I feel like I've definitely seen less of a barrier to access that kind of knowledge over the past 3, 4, 5 years. Um,
For sure, it's only going to get easier too, right? Yeah.
yeah, yeah, no, exactly. Given the skills that you've outlined that consulting engineers will benefit from going forward, what type of professional development or training do you think could be useful for engineers?
Well, I think that that's a good question. I would say that there's two places that as maybe as a group, as engineers as a group should really focus, and I think it's looking at what we're learning in school. I think back to what I learned in school. I think I took, as a mechanical engineer, I took like one course in Java, and then that was it. And a lot of the courses I took were first principle based and very theoretical in nature, as it relates to mechanical engineering. But I think as you know a, as an organization like OSPI or the PEO, we should also be focusing with the academic institutions to really focus on some of these skills. I think that there are a lot more opportunities than there were before. I went to school maybe, well, I'm dating myself here, but I graduated in 2008. But with our research project with Queens, obviously they have a large AI computer vision group there, and they're teaching that. I know folks that are coming out of school right now are already learning those skills. For those of us that are already in the industry, again, it's similar to the answer before. It's finding something that you're interested in. There's lots of formal education that you can do in data science. There's lots of informal education or certifications, formal certifications that you can get through the different cloud practices. And like I said, IoT. I think for IoT, you just have to get into it. You have to try it. For us internally as an organization, we formed a group and we started doing research. And the research led us to some partnerships and implementations within our own office and gave folks the opportunity to actually try the technologies themselves. The IoT project within our own office, we did partner with a startup, but we were able to access the data through their API, and some of the folks in our organization got to just tinker away at that. A lot of it is just trying it out and seeing where it goes.
Well, that's great. And I think when we talk about AI, we see it creeping into all different aspects of life. So how long do you think it'll take the majority of medium to small size engineering firms to use AI technology in their daily tasks?
I mean, I would say I would say it's within the 10-year time frame. And it's going to be in different forms. I mean, I think one of the things that people are concerned about perhaps is that, a lot of design will be automated. And that may in fact be the case. And when you look at the type of work, let's say we do in engineering consulting, let's say building systems design, I feel like there's a lot of things that could be automated because a lot of the things that we do are somewhat repetitive, or they're already optimized around the most efficient way to do something. Right? There's a reason why buildings are rectangular, and there's a reason why the slab to slab height of a patient care tower is I think what 4.2 meters or something like that, because based off the codes and standards and design requirements, everything is already kind of converging on the best way to do things. So there's no reason why a more sophisticated software could provide us these solutions. But this is all to say that the software will be a companion to the engineer, right? There's certain things that AI and machine learning just won't ever be good at least in the near term. And those are things like interacting with people or making decisions based off aesthetics or making decisions based off of what's best, for people. So what we'll start to see, and we're already seeing, is that the software tools are companions to us. They help us make decisions, give us options, and we'll just find that the decisions and options that they're making are going to become more sophisticated. So, I mean, in my mind, like I said, I think easily within a 10-year time frame.
As we start to look at more cloud-based structures, do you see business-critical data being stored in the cloud? And then what are any guarantees we have around security or a disaster recovery effort?
That's a really good question. When I look at our own organization, I think what we're seeing, for instance, regardless of what we seem to be, things that we try and put in place to minimize it, data propagation is increasing faster than it ever has. So, in terms of an on-prem solution for storing our data, it's become really costly. It's like we're adding more storage, and the more storage you add, the more it gets chewed up. And whether that's just because of the types of softwares we're using, the design files are getting bigger, even using traditionally digital cameras or images from your phone. Now we're using 360 cameras, 360 4K video to capture site information. Like, the size of the files are just increasing. So I think I think we have to accept the fact that we're moving into the cloud. In terms of resiliency within the cloud, versus on-prem, I think the answer is very simple. It's like there is much more resiliency for storing your data on the cloud, because it's typically if you're on a major cloud service, it's backed up geographically, and it's sorry, I'm having a brain fart here, but the data is backed up geographically in different data centers around the world, depending on what your data restrictions are, whether they have to remain in Canada or in the US or something like that. But the fact is that it's going to be more secure there than it is on your on-prem servers. In terms of security, that's a really good question. When it comes to security of your data on the cloud, or if you're using an application, or if you're creating an application, right? That's kind of divided into two places, because there is a burden of security on your end. You have to be the one that's managing your user access and user accounts and whatnot, and making sure that those are secure, right? Like phishing scams are all over the place. We get emails all the time where people are trying to get our passwords and things like that, and we hear often organizations being taken hostage, right? Their systems get taken over, and then that's obviously a big challenge. But that burden of the security is actually on our end, right? And the cloud has their responsibility to keep the data secure on their end. But I would say that a lot of data breaches probably come from the user side or the end, and so that's something that we have to learn, and IT organizations or groups within our organizations obviously are doing their best to keep up with what's happening. So I think when it comes to security, we have to take on the responsibility ourselves for that, as engineering organizations, as it relates to the things that we're responsible for.
This next question is actually questions that I had as well. So I appreciate this being asked. But in your experience at HH Angus, um, how do you foster an environment of continuous learning and creating efficiencies?
um, I think it's certainly a major challenge in an organization because ultimately we are trying to you know we're trying to make money, and we're trying to be efficient in how we deliver our work, and often you know the fastest way to do something is the way we've done it before. So it's you have to move against you're going against the tendency of the organization to continue the way it is to make change. But internally, we do have a learning and development committee, which is really focused on understanding and getting the needs of the folks within the organization and understanding, the needs strategically that will help the company, but also at the individual level, the things that they're interested in, and making sure that those things are identified and folks are given the opportunity to do that. I think that, um, you know, within HH Angus, also over the last few years, based off what we've talked about here, is we and I and my group and other folks have been given the opportunity to try different things just based off of new technologies that are out there. But I think it really comes down to seeking the opportunities with your clients when they identify a challenge and finding, and suggesting or saying that maybe you could try something different, or having the folks in your organization, be aware of the different research projects that you're doing or different technologies that you're trying to bring into the organization, and suggesting those things as different services. I think that it's really obviously the things that we do as related to innovation, they have to be aligned with the work that we do, and they have to be aligned with the challenges that our clients have, so that there's a mutual benefit there. So I think it's at least having an organization that's open to trying something new. And like I said, these research partnerships have been really interesting, and there's a lot available to connect academic institutions to industry partners.
I can see it challenging, myself coming from a very traditional engineering space and environment and then moving into toys. So being in more traditional spaces, having any kind of digital adaptation, there's a lot of resistance to change, and it's hard. So I don't know if you have any advice around that to actually like push that thing forward and open people's minds up to maybe something new.
Change management is tough, right? And I think that you have to address when it comes to any kind of change management, you have to address what it is that are that are the concerns of the folks that may be resistors, right? I think generally you can, people may have heard this before, but there's like the 10-80-10 rule, right? Where there's like 10% of your folks are going to be early adopters or really pro change. There's going to be 80% of the folks that will come along, some easier than others, and then there might be 10% of the folks that are really going to dig their heels in and be resistors. But I think the key is making sure that you're communicating why you're doing what you're doing or why you're making the changes that you're making, and also talking to the folks that are resisting and trying to understand why they're resisting, because a lot of the cases probably has nothing to do with the fact that that they don't necessarily want to see the change coming. They may be concerned about how they're able to adapt to it, and if you provide the resources and the training and the guidance and to make sure that you're bringing those folks along, then I think it goes a lot more easily. That all said, change management is probably one of the most challenging things in any organization, right? And it's hard now because things are changing so quickly, right? So it is it's never easy.
Yeah, no, for sure. There's a question around asking if you can go into some detail regarding the validation of data sets. Big data is key to AI, hence the applicability of this data is key to a valid output of the tools used.
Well, I'll be the first to say that, I am not a data scientist, so it's certainly going to be challenging for me to answer this question. Validating big data sets, I think, when we think back to the project that we did with Ryerson, after we're still seeing some of the results come through, and after I created this presentation, we saw some of the results of the other models that have come through, and I think that it just takes, obviously it takes a lot of data, and I think that you just need to have the folks that have the expertise to understand that the models that are being generated, what is it that they're saying, right? And I think that you know, beyond that, it's difficult for me to kind of, I'll be honest, to answer that question, because I wasn't really involved in the specific analysis of that. But I think that hopefully I've kind of danced around that as best I could. But it's certainly a challenge, yeah.
Going back to the learning and development piece, if someone were to look into significant recognized certifications that can be done to gain a proficiency in AI or machine learning models, any suggestions you have?
Well, I mean, I think that, for instance, if you look into, AWS, there's a lot of different professional certifications. You can get the cloud practitioner that kind of gets you into understanding all the different web services, and then beyond that, you can either look into, solution architecture, so understanding how all these pieces fit together. There's specialties in data analytics and machine learning, and how you can leverage those. Different aspects of the tools as well. So that's certainly one way that you could get into that. In terms of machine learning and AI, informally, I think that there are lots of courses available, let's say on LinkedIn Learning or whatnot, where you can start to get into it. A lot of it starts with just understanding how to program in Python, I think, and I think there are courses that you can take, but again, you have to get a good data set to work on with them. And the difference is that when you are in those courses, you're getting a very clean data set, right? So which isn't often what you're getting in the real world. So it does certainly teach you the skills, but then applying it in the real world, going back to that previous question and saying, okay, how do we make sure that the data set that we have is clean, and organized and categorized in a way that allows us to analyze it? That's a whole other challenge, and I mean, it's a whole field of interest, right? Like data science is very big these days, and it's certainly a big a complex skill to learn.
This next question really, I feel like, talks about the future of Canadian innovation. And if you're aware of or are part of any current industry or OSPI related initiatives to really bring AI innovation to uh, to our future engineers who are currently in school, whether it's grade school or high school, and how are we engaging that generation of engineers to start to think differently?
That's a big question. I mean, I'm currently not involved in anything at through OSPI on this, but I mean, I think in general, um, you know, just thinking about it from my own children. I have two young boys, but they're not even school age yet. I think about bringing in how to teach them the skills to kind of make them prepare for the future. I mean, there's like, there's coding camps that you can go to, and whether it's a summer camp or extracurricular, programs where you have kids learn coding. I mean, I think that's really kind of the aspect to it. But that being said, when you look at kids, right, it's I think the people being born right now, it's going to become much more second nature because it's going to be a big part of their environment growing up. Those are things that the challenge is for people like us, or people my age or older to adopt this, because the young folks will, I feel, learn as they go along. look at how quickly, my 2.5-year-old can pick up my phone and start taking pictures. And I've never showed him how to do that. I don't want him to do that, but he has figured it out, right? So I'm less concerned, as long as I think, this kind of really, we can go into great detail about this when we think about what the curriculum is for our public education system. That's something that I think we could talk about for a long time. But as long as those things are kind of moving into and being taught at our schools, I think that it will become second nature to the young folks as they grow up. But that's a
Yeah,
really
no, I think
complicated question.
it is, and I definitely appreciate the answer. But I think this has been great. I think it's been extremely informative. I want to thank you for your time.
Oh, it's been my pleasure. Yeah, and it's certainly I appreciate the opportunity.
Yeah. And a big thank you to the audience, and everyone can head to their next session starting in at 9:30. You can check out the agenda tab on the left navigation menu to access links. Again, thank you so much, Akira, and thank you to the audience for joining. And I hope you guys enjoy the rest of the conference.